All right, my name is Matthew Glenn. I'm the SVP of Product Management at Illumio. Today we're going to talk about how Illumio solves a number of the zero trust use cases outlined during the ATARC sessions we've been having over the last few months. I encourage you, if you have any questions, pop them in the chat, and I will also, at different moments, take time to see if there's any questions from the attendees. So just let's go ahead and get into it. And once again, we're going to do a bunch of demonstrations that specifically address all of the demonstrations at ATARC we've been talking about over the last few months. However, there's way more that Illumio does beyond what we're demonstrating here today. We'll talk about some of those things. We'll even do some freestyle demos towards the end, because that's one thing that we love to do with our product, is to show more than tell. So here we go. If you don't know anything about Illumio, we have probably the largest zero trust segmentation deployments in the world. Nine of the largest 15 banks, the largest business-to-business SaaS providers, including companies like Salesforce.com, use our product. So if you're thinking about a product that's actually built for the cloud, the biggest cloud companies in the world use Illumio for their zero trust segmentation. We have what I can attest to being the largest zero trust segmentation deployments in the world. And we have millions of workloads out there in deployment and in enforcement. It's not just that we've done a lot of deployments, we have a lot of very happy customers. You can see a smattering of them on the screen right there, including Raytheon, Fannie Mae, Harris, and Leidos as a partner. Gartner Peer Insights, where customers talk to Gartner, we get a 4.6 rating there. In the most recent Forrester Zero Trust Wave, Illumio appeared in the top right-hand corner of their assessment of the different vendors. And finally, in terms of federal certifications, we are already FIPS validated, Common Criteria validated. We're on the Homeland Security CDM list. We are in the process of FedRAMP right now. We think we'll be FedRAMP ready around February of next year, okay? All right, so here we go. So if we were in an elevator and you asked me what Illumio does, we really do three things. In your existing environment, this existing environment might be on-prem, it might be running in the cloud. We're going to build a map of how things communicate with one another. This is not a guess of a map. It's a high-fidelity map that shows every communication between any workloads, whether those workloads are bare metal servers, VMs, and/or containers. That map is in service of building up a zero-trust segmentation policy. So in your brownfield environment, you're going to use the map to safely build a zero-trust strategy and enforcement solution that's going to basically ensure that you're protecting your applications, but you're not breaking them, because the map helps you build safe policies based on the traffic, not based on a Visio diagram that was built who knows when. So in the brownfield, you're going to start with number one and get to number two. However, we have customers that every day launch brand new applications. Those customers are, Salesforce, Workday, banks like BNP Paribas. And what they do is every time they launch a brand new application, it inherits a zero trust policy. So they start at number two, but when they launch that, it's still going to build a map of how it's communicating into their existing environment. So in anything that's net new, anything brand new in the cloud, you'll start to number two, but you're still going to get number one. But regardless of whether you're in a brownfield environment or a greenfield environment, what Illumio does is we isolate your high-value assets, dramatically reduce your attack service, all to ensure that if there's ransomware or if there's some type of malware within your environment, it can't move laterally in any way, shape, or form. All right, before we get in, as we get through this, I want to start off by talking about our architecture. So our architecture is not tied to your network in any way, shape, or form. In fact, when we get to the demos here today, I'm actually going to show you workloads running in cloud, running on-prem. We are completely abstracted from the underlying infrastructure. There's no reliance on the hypervisor. There's no reliance on the switching infrastructure. We assume you're going to have bare metal servers. We assume you're going to have VMs. We assume you're going to have containers. So rather than going to where your network is, because you might be in your own data center, you might be in public cloud, we go to where your compute is to do visibility and segmentation. So in our base form, our solution is comprised of two pieces of software. The first piece of software is on the left side of your screen. It's that little box that looks like it has a V in it. We call a VEN, or a virtual enforcement node. Now, the name is actually rather funny because it does not enforce any form of policy. It's not in line. It doesn't do any form of deep packet inspection. Traffic never goes through it. One of my customers calls it an antenna, and I've sort of adopted that term because what does an antenna do is it sends and receives information. In this case, it's going to give us context and telemetry about the workloads where it's installed. It's going to tell us what interfaces are on those hosts, what are the listening processes on those hosts. It's going to tell us what's talking to that host and what that host is talking to. And it's going to send it up to that box in the middle of your screen we call a policy compute engine. Now, the policy compute engine is a multi-tenant SaaS, which is why, of course, we are getting FedRAMP certified right now. But we also deliver it on-prem. It's the same exact software. It was designed as a multi-tenant SaaS, but some customers, especially in regulated industries, decide to take it on-prem. The first thing that you're going to get out of it is a live application dependency map. This map is the truth of how things are communicating within your cloud environment or your on-prem environment. And what you're going to do with that is you're going to use that map to construct zero trust security policies, specifically around segmentation. And you're not going to do it based on IP addresses. Instead, you're going to describe how you want things to communicate in natural language. Like for my enrollment application, I want the web tier opened up to my load balancers. The web tier talks to an app tier talks to a database tier, something that any human can understand. What that policy compute engine does, it's really just a brain. It's going to take that natural language policy that you write, couple it with that context and telemetry from the individual workloads, and compute layer 3, layer 4 policies and send it back down to those VENs, those antennas that I spoke about. And the VENs don't enforce the policy. But what they do is they enforce the native stateful firewalls that you already have inside of those systems. So in Linux, we use IP tables or NF tables, depending on which version of Linux you're running, whether it's Red Hat 8 or later or before. For Solaris, we use IP filter. For AIX, we use IP filter. For Windows, we use the Windows filtering platform because it scales way more than the Windows firewall. And there's some things that we can't put our VEN on. So for those things, we use an API level integration to program them. So we'll actually program the dynamic address groups inside of your Palo Alto networks. We'll take your F5 load balancers and turn them into points of visibility and points of enforcement. We'll do that for the VMware Advanced Load Balancer. We'll tell you what the ACLs would, for an on-prem solution, would need to be for a Cisco and Arista switch. But then we'll also program the security groups inside of your Azure deployments and your AWS GovCloud deployments. And finally, we'll even instruct the native stateful firewalls that are inside of your mainframe, as well as in your I-series, your AS400s. Effectively, just to do a quick Vulcan mind meld with everybody, we're all about allowing you to use all the enforcement points you have, because we think you have, you don't need any more enforcement points. You just need a way to leverage them, and Illumio does that, okay? Now, that all works great when you want to put the agents on things, and I alluded to the fact that we can do agentless also by programming security groups. So let's talk about how the architecture evolves to solve those types of solutions. So I talked about the data center component. We can also extend this out on one plane of visibility to solve the endpoint problem. In fact, some of the demonstrations we're going to be doing today actually are on the endpoint. And finally, if you want to do it agentlessly in your deployment, we can actually read the API keys of your AWS, GovCloud, Azure GovCloud environments, send that to the policy compute engine in a read-only mode, and actually calculate what the rules would be for the security groups that you've already deployed. Or if you already have the security groups, we can tell you how to make them better. So what we deliver is one plane of visibility and one plane of enforcement for your bare metal servers, your VMs, your containers, your IaaS instances, and even your PaaS instances, one plane of visibility and one plane of enforcement, okay? Now, I'm gonna now that we've sort of done a overview of the architecture, I wanna just show you a quick preview of what you're gonna see, and then we're gonna go back and start mapping it to some of the zero trust frameworks that we all know and love. So I had already logged in, but really quickly, so I was about to be logged out right there. I'm glad I swapped over just in time. So here are all the locations where this organization has compute. You can see some is in Washington. We have some in Azure, some in GovCloud. I've modeled out some interagency traffic in this. We have a remote office in a St. Louis location. So this view is what we call the location view inside of Illumio. Now, think about this as sort of almost like a Google Maps, and we're going to start getting deeper and deeper. This is how I'm going to show you the plane of visibility that we provide. So I'm going to go a little bit further into this Washington data center, and I'm going to show you a few things. The first thing that you're going to see are that there is these circles, and then there's lines between those circles. Each one of these circles is one application instance running inside of this Washington data center. You'll also notice that there's numbers. The numbers here indicate the number of workloads that are part of that application instance. And the lines indicate that there's traffic going between these individual application instances. Now, if I go further here, now it's almost like looking down at the Google Street View. Remember when I talked about the context and telemetry going up to the policy compute engine? Let's talk about what I mean by that. So I'm just going to select this database right here, and let's take a deeper look at what's going on with it. So here are the interfaces running on these systems. I want you to notice a couple things. There's IPv4 addresses, and there's the IPv6 down here. This demo instance has been up for 52 days. My entire demo today is actually running inside of Amazon. So just to sort of prove that we're abstracted from the network infrastructure, the operating system type. Here are the tags and labels associated with it. And when we get to the mapping of the ATARC frameworks, we'll talk about where these tags and labels come from. Here's the role, and this is, remember, it was a database for the TSAP application in the production environment in Washington, D.C., okay? Here are the listening processes on this specific host, okay? And here are the rules. And I want to sort of point out that we do both inbound and outbound rules on a per system basis, okay? Now, going back to our map right here, what you're going to notice here is that there are red and blue lines on it, okay? A red line indicates that we've detected traffic and you've not yet written a policy that would allow that traffic. A blue line indicates that we've detected traffic and that traffic conforms to a policy that you've already written. Now here is an important point here, okay? When you first deploy the solution, you're going to start off in visibility mode. In visibility mode, we're just going to start showing you all these application topologies, okay? Now, you can begin to write policies, and as you write the policies, you'll see blue lines overlaying those red lines. And what that's doing is giving you an indicator that the traffic that you've written, the policies that you've written, conform to the traffic that we've seen, and so it wouldn't be blocked, okay? You can begin to enforce policies, like you could say, hey, I want to enforce access from my jump host only on port 22. So you can put a port on one of these systems into enforcement while leaving the rest of the host in visibility mode. And we'll be doing some demonstrations on that in a little while. And finally, at any time, you could take any workload or any application and put it into full enforcement mode. At that point, you've reached perfect zero trust. But the benefit here is that we give you a nice on-ramp. You start off in visibility mode. You can begin to enforce traffic at the port level. In fact, you can block ransomware using this selective enforcement capability. You can incrementally build up your policies using selective enforcement. And when you're ready to, you can reach full zero trust. A couple last things I want to point out to you about on this map. I'm showing you the location map right now. I can also show you this application from an application owner view, because as it turns out, this application really isn't running in one data center. It's actually running in 2 data centers. You can see it's also running in the TSAP and GovCloud. We see this very commonly because very frequently applications don't live in one location. They actually live across multiples. And the reason why that happens is that the geographic diversity creates resilient application architectures. Now I want to show you the application owner view. So this is how an application owner might view the application. So it's literally everything that we previously showed you. It's just from the application owner perspective. Couple last things I want to point out to everyone. This right here is what we call an IP list. An IP list is a set of IP addresses that doesn't have our agent on it. It could be for interagency traffic. In fact, we're going to show that to you in a couple of moments. It could be for an area of your network where you don't use Illumio and you want to provide inbound access. And then finally, this globe right here is giving you visibility into the fully qualified domain names that this system is talking to. So you can see all the, this is probably the updating services that we have here. So that was just sort of my quick orientation to the product before we get into the actual demos that correspond to what ATARC was looking for. So let's go ahead and go back to my presentation. And what we're going to do now is talk about the solution prerequisites. Everything that I'm going to talk about today is available online. And in fact, if you simply go to docs.illumio.com, there's all kinds of great information. You can read all of our documentation here. You can see all the different OS support that we have. You can read deployment guides. We're very open. You don't have to be a paying customer in order to read our documentation. I'd also like to call your attention to the fact that everything I'm doing in the UI today is driving the exact same REST API that you have access to. So we have customers that use our UI all the time, and that's great. And we have some customers that just drive our entire product from the API. The benefit here is you don't have to worry about I can only do this in the UI, or I can do this in the API. Everything that we do today in our demonstration is fully available in our API. Okay. Now, if you have other questions, just contact federalsales@illumio.com. We're happy to do a deeper dive on anything that we talk about. Okay, so let's talk about the functional solution and how it covers the zero trust architecture. The first thing I wanted to talk about was actually before I go, there's action from the field. Can you provide data with your contact information? The answer is yes, and we're gonna we will federalsales@illumio.com, and at the end of this presentation, you will have the actual contact, and the presentation will be available online at the end of this. Okay. So let's talk about how Illumio maps to the TIC3 compliance. So in terms of what we do, we tried to map this into things Illumio fully supports and things that we partially support, but via API integrations or other types of integrations that we already have, actually fully solve. Okay. So in terms of managing traffic, Illumio fully solves that, because you'll see as we go through my demonstrations today, us allowing and denying traffic. In terms of protecting traffic confidentiality, you will see with a click of a button today that we can basically on-demand encrypt data in motion, but instead of having to refactor an application to use HTTPS TLS, we're going to use the native IPsec capabilities that are already inside of your system, so we can do that from Windows to Windows, Windows to Linux, and Linux to Linux with a click of a button. Protecting traffic integrity, we do partially, and we have partners that we work with on that. Service resiliency, you will see, number one, that the actual architecture is very much resilient. In fact, that policy compute engine isn't one box, it's actually a distributed system. If you read our PCE deployment guide, you will You will see exactly how it's geographically distributed and resilient. And also, you can dynamically quarantine things to ensure effective response. So in terms of a networking policy enforcement point, or PEP, we can take care of access control. We can do deny listing. We can dynamically quarantine a host. Everything we're talking about really above is really about network segmentation. And then also, Illumio is the leader in micro-segmentation. Now, mapping this into the ATARC Zero Trust Capability Model, we spent a lot of time looking at this for you. And for data encryption, device authentication, cloud-based software deployment and management, network segmentation, software-defined perimeter, we do everything required there: micro-segmentation, application segmentation, all those sorts of areas that ATARC called out. We actually did a mapping of what we do to this. And this is exactly what we fully solve in their out-of-the-box capabilities. Also, if you look at the things that we do partially, we also accounted for them there. And I want to point out that when we after this presentation is done, you will be able to take a look at this, how we mapped their core pillars to the ATARC core pillars. It will be fully available, as well as our sales contact information, okay? So going a little bit further, we also did a mapping, because this was required for the ATARC presentation today, of how we mapped to 800-53, the security and privacy controls for information systems, okay? So we basically looked at, from this perspective, identify, protect, detect, respond, recover, what we do for each function. We talked about what we fully support. There was none that we did partials on here, but we did a lot of what was required for 800-53. And of course, this will also be available in the presentation that will be left behind. And then let's map this to 800-207, okay? So what we decided to do was map that architecture that we showed you earlier to the 800-207 Zero Trust architecture. So the first thing I'd like you to note is that the policy compute engine is the policy decision point. It has both PE and policy administration capabilities. So this is where you're going to get interface. You can define policies in that policy compute engine. So it is the PDP of our solution. It also has IAC templates for enforcement to the policy enforcement points, okay? What are the policy enforcement points? The answer is the VEN is actually going to program the enforcement points that are in the native operating systems. So this is the native stateful layer 3, layer 4 firewalls that are inside of your operating systems. For those things we can't put the VEN on, what we do is we create an API level integration with things like your security groups inside of GovCloud or on-prem. We program load balancers to turn those into enforcement points using the native APIs. And then also, we will tell you what can go on a switch port or otherwise. So what we are actively doing is we are basically using what you already have and using the policy enforcement points or the PEPs that you already have through this architecture. Finally, what are all of the policy information points? Earlier I showed you the REST APIs inside of the policy compute engine. Those are commonly used as policy information points that are used with API level integrations with like your SIM, also with SOAR. This is also where information can be brought into the system from your CMDB. And also we'll even take your vulnerability data and overlay that on top of the application dependency maps that I showed earlier. So through those API integrations, we provide multiple policy information points. And we'll dive a little bit more into that in the next slide. I'm going to pause for a second, see if there's any questions about anything I've said earlier while I just get a quick drink of water. All right, cool. So that said, let's go ahead and talk about how the PIPs come together with the 800-207. So if you look at all of your PIPs out there, your CDM systems, your threat intel, your logs, your PKI, all of that gets plugged into the policy compute engine, or actually the policy compute engine will feed them. Like the SIM is not plugging into the PCE. We send data to the SIM. We'll actually, for user authentication, we'll send the authentication to your ID management system. We'll get, a yes or no from whatever ID management you have. But, through our APIs, we're able to either take in information or export information to all of these systems. What is important on this is that all of the traffic is going to stay in the data plane. So the policy compute engine is the PDP here, and it's also going to allow you to do policy administration. It will in turn program the policy enforcement points that's going to control whether an untrusted system can talk to a trusted system. So that policy and promotion point might be, an a Palo Alto firewall. That policy enforcement point might be a host firewall running inside of your network that's interfacing with a partner network. So what we're effectively doing is enacting the PDPs that you already have, but without in any way, shape, or form having you modify the underlying infrastructure. There's no reliance on changing an IP address, subnet zone, or VLAN in order to make this work. So you don't have to refactor your network. And in fact, we'll talk about that, I believe, in the next slide. So what are the key differentiators for Illumio? So the first thing is we can achieve real-time visibility and accurate visibility into your network traffic. And I want to sort of make a fine point on this. Earlier, I talked about the architecture, how the VENs are taking traffic and programming the native stateful firewalls. The benefit of this is we see every connection open and every connection close within your environment. So this isn't a guess or a sampled view into the traffic inside of your infrastructure. This is high fidelity. We see every single connection open and connection close. Likewise, this allows you to see where you might have risk, and we'll show you an example of that in a few moments when we get into the demonstration. Also, this is done without any modification to the underlying network. If anyone's asking you to modify the kernel of a host, asking you to change the network infrastructure in any way, shape, or form to get to zero trust, that's not going to work because the change model changed their network applications in order to get to because spread out. There's no need to change your underlying network. If you're running an SDN, fantastic. We work great with SDN. If you haven't used SDN, that's great. We work completely fine with that. If you're half and half or in that transition, that's absolutely fine too. There's no reliance on the underlying network, and the same controls that you run inside of your own network also work equally well in the cloud, and that's because there is no reliance on the underlying infrastructure. And of course, for those things where we do it agentlessly, using Cloud Secure, what we are effectively doing is just reading the information out of your cloud console to feed what we're visualizing and then allowing you to enforce on, okay? This allows you, that visibility allows you to accelerate your segmentation at any scale. We have customers that start off with like 10 hosts that they really just want to put a ring fence around, and that's fine, that's their end state. And we have customers with hundreds of thousands of workloads in enforcement. It doesn't matter where you start, we can start small and grow, but the benefit of the architectural approach is you're not ripping out your infrastructure in order to getting to zero trust. You can incrementally add zero trust as you need to. Likewise, you can start with the things that matter, the things that actually are carrying your application traffic. This is your endpoints, i.e. the ones that I'm sitting in front of right now, a laptop or a VDI instance, both of which we'll show you during the upcoming demonstrations. It could be a workload, and a workload being a bare metal server, VM, and container, and cloud instances where we can't put our agent. PaaS serve systems like an RDS or managed database, or even a Lambda function running inside of GovCloud. The benefit here is you can get to zero trust quickly and realize very quick wins, both of which I'm going to show you in my demo in a couple moments. Also, a benefit is you can do any scale of segmentation without changing the underlying infrastructure. One of our first large deployments was a global financial company, and they had about 17,500 development hosts literally spread throughout the world. And their use case sounds fundamentally simple, which was they wanted to do development production separation. The problem was their development environment was in the same IP address ranges as their network environment. So in order for them to do dev prod separation, they would have had to refactor, re-IP, re-VLAN their entire infrastructure. With Illumio, they deployed the agent. They wrote one rule, which is my development systems can talk to my development systems, and Illumio converges that policy globally, but without having to modify the network. As I said earlier, this works equally well across your existing flat network, your SDN network, and cloud network, and in fact, it works across them. You don't have to worry like, hey, I'm running my SDN running on my network in location A, and I'm in GovCloud. It works exactly the same, and my visualizations that I've shown you demonstrate exactly that. And one of the things I just want you to quickly note, most applications don't often fit in one data center. Frequently, geodiversity creates resilient architectures, so we fully expect that part of an application might sit in GovCloud and part of it might sit on-prem, or even more often, you might have an application sitting in GovCloud talking to something on-prem like a mainframe. That's absolutely fine, okay? Finally, and this is a critical point to zero trust, you will never, ever, ever have to worry about rule ordering when you use Illumio. The policy compute engine, that brain that I was speaking of, understands the intent of all policies that you're trying to write, and you will never have to worry about a rule conflict. And that is the essence of zero trust. You only allow what you must, what you absolutely know. And once you start going down the deny listing thing without a solution like Illumio, what you're actually doing is digging a hole when you're going to have to worry about firewall rule ordering, and it makes it almost impossible to get to zero trust. All right? So if you have next question on the ATARC thing was about licensing information, just contact federalsales@illumio.com. All that will be available to you. Okay? For a full listing of current customers, I put a smattering them at the top of the demonstration. Just contact federalsales@illumio.com. All right. Let's get into our demonstration. That was actually my favorite part of the TV show today. So, but before I do, if you have any questions, just pop them in the chat while I'm doing my demonstration, because we want to make sure that, as we're going through this, there'll be lots of different things that I talk about. Maybe there's a question that you have, and I'm not clear. I'm not always clear in everything I say, so just feel free to pop those questions into the chat, and I will do everything I can to answer them in real time. Also, it'll make it more fun. If you want me to try something with the demo, I often will freestyle if you want me to, okay? So what we do to proactively stop cyber attacks and contain ransomware is you'll start off with visibility, and we're going to show you all that. We'll use that visibility to create policy designs, and then we'll enforce zero trust segmentations. We'll also allow you to create views. Earlier, I showed you that application owner view. I could say, like, Kirsten Patton is the owner of the fingerprint application. She would log in, and she would only see the fingerprint application, okay? So we don't just apply zero trust to segmentation, we also apply zero trust to how people interact with the product. And then we're continuously monitoring all the systems where we're deployed. And if anything spurious happens, you're going to get an alert to your favorite SIEM, Splunk, ArcSight, QRadar, or whatever it is that you want to use, okay? So here is the setup for the demonstration today. So we chose to basically model the DHS, and DHS has deployed Illumio, okay? DHS has an application that connects to the FBI to consume some fingerprint services. But also the FBI connects to DHS to consume the iPod service, okay? DHS has VPN deployed and ICAM deployed, okay? Now, DHS is a large organization, so they have contractors. So, and the contractors are going to be able to access some of those systems, right? But we don't want to fully trust them and allow them to get into production. So, we're in the land of COVID right now, so we're going to show a contractor coming in through a VPN, and also a user, if they were on-prem, accessing it via VDI. And then finally, we're going to show the FBI accessing the iPOS application running inside of DHS. So that's just a couple of the setups here, because we're really trying to be very strict about what ATARC was asking for in these demonstrations. So this was the first setup that we wanted to get to, okay? So this eye chart is all the different threat vectors you would have in a flat network, right? Once a contractor comes in through a VPN, they can move anywhere that they want to laterally, and this section right here is our DHS environment. So they can move anywhere that they wanted to. Let me just sort of point this out really quickly. They can move anywhere they want to once they're in the VPN inside of this entire environment, whether that is an on-prem environment or a cloud environment. So what we're going to do is I'm going to show you a couple of the threat vectors. So the first one, the use cases that we're going through from ATARC is use case 3, which is a contractor with admin privileges going into the DHS cloud, okay? The DHS cloud, they have admin access to resources from a VDI instance once they VPN in to a dev instance and a production instance of an application. And that same application can do an on-prem access also, okay? Now, those are the use cases we're going to solve first. And just so visually, so we're all reading from the same page of the playbook, the first one is VPNing into GovCloud and accessing this TSA pre application in the production environment, okay? Use case 4 from ATARC is actually VPNing in and accessing the on-prem instance of the exact same application, okay? So let's get out of PowerPoint and let's get back into our demonstration system, okay? So really quickly, as I do my demonstration, if you want to understand how we get to the F5 load balancer, I'm just going to post something into the chat window to everybody. One second. Everyone, docs.illumio.com, okay? All the documentation there. If you want to know how we work with F5, just enter F5 in the search button, and you're going to get the answers to that. But now back to my demonstration. So really quickly here, here is all the locations where this organization has compute, okay? I also want to point out that in our GovCloud, we have an instance of that TSA pre application, but that TSA pre application also is also in an on-prem instance. You can see it right here, okay? That's the on-prem version, and I just showed you the cloud instance, okay? Also here, we have this VDI instance for those TSA pre-contractors, and we can see that they're talking to that TSA pre-prod instance right here. So let's go ahead and talk about how we write the policies that allows that contractor to access different things, okay? The first thing is what we did is we wanted to basically only allow the contractors to come into their VDI instance. So what we did was we created an IP list that corresponds to the VPN IPs that the contractors are allowed to come in on, and they're only allowed to come into the VDI instance. Want to remind you, Illumio is zero trust by default. Unless you explicitly allow something, it is by default denied. If I had not written this policy, the contractors wouldn't even be able to connect to anything where Illumio is deployed or Illumio is enforcing policy on other types of infrastructure. So this first policy is only allowing that remote user to land inside of the DHS network, okay? Now, the next policy I'm going to write, and this is something I absolutely love about the product, is I can basically write a policy for both the on-prem version of the TSA pre-application and the cloud version of the TSA pre-application. And let me show exactly how you do that. This is what we call a scope. A scope defines the instances of an application where that a policy is going to apply to. In this case, I wrote a policy that is applying to the TSA pre-application in the development environment across all locations where it's running, okay? That means if the TSA pre-environment is running on-prem or the TSA pre-application is running in GovCloud, it's gonna get the exact same policy, okay? So in this one rule, what I'm effectively doing is addressing the on-prem instance and the cloud instance. I don't have to start thinking differently of on-prem versus cloud. If I had written it saying, GovCloud or on-prem, that you can absolutely do that, but by simply saying all locations where it's running, it gives you location abstraction and location flexibility, so you don't have to rewrite the same thing over and over again. It's a very efficient way to write policy, okay? Likewise, I've written it for the production environment and the development environment. Because these are on two separate lines, it's ensuring that I'm not commingling these applications. It's literally just each line of the scope is a policy template. It's a very simple way of thinking about these things. Here is my policy. For the TSA pre-application, each instance of the TSA pre-application, all workloads can speak to all workloads. What this is effectively doing is, even though this application might be spread out across multiple locations, I'm going to write inbound and outbound stateful layer 3, layer 4 firewalls that allows the instances of the workload to communicate with one another, okay? What I've done next, though, is really the important thing. I'm restricting what that contractor can connect to. What I've said is that VDI instance, and remember earlier how I talked about how the contractors could only get to the VDI instance of the TSA contractors that are in the production environment, and here is the kicker on this. Only those people that in Active Directory, so based on their user identity, only those that are part of the application admins can speak to this TSA pre-application, and they can only do it on the administrative ports, i.e. RDP, which is port 3389, UDP, and TCP, and if they were a Linux admin, it would be SSH, okay? So what this policy does is that VDI contractor can't connect to everything. The contractor can only speak to those instances of the TSA pre-application that I granted that contractor access to, but it can't speak to all ports. It can only speak to the administrative ports, which was explicitly what ATARC's use case 3 and use case 4 asked for. What we've done is we've taken a fundamentally flat network and we've restricted what that contractor is able to do using these fine-grained segmentation policies. The contractor can only connect to those things that we gave the contractor access to. So we took a flat network, we didn't modify it in any way, shape, or form, and we created zero trust segmentation policies that governed how this contractor can get into the DHS data center as well as the DHS GovCloud. Okay, so that was use case 3 and use case 4. Now we're going to do something really cool. So use cases 5, 6, 7, and 8 was about interagency traffic, okay? What we did here for this is that fingerprint app that the administrator has access to, we also have people working at DHS that use that every single day. That TSA pre-app is something that we have people using every single day. But that app needs to also interface with the FBI, the FBI's fingerprint app, excuse me. I hope I'm being clearer, okay? So the TSA pre-app needs to speak to the FBI fingerprint app, but let's be very precise about that. That fingerprint app does not reside inside of the DHS network, okay? And there's 4 different versions that ATARC asked us to address here. The first one is that the app in cloud needs to be able to access it. The on-prem needs to be able to access it, both on-prem and in the cloud. and the on-prem instance needs to be able to access the cloud instance, and the cloud instance needs to be able to access the on-prem instance. So sort of the exact same problem, but done 4 different ways, okay? So how are we going to do that? Let's go back to our sort of diagram here. So the first thing I want to draw your attention to is that, I think I went too far, okay, is here, just as a reminder, here's our DHS network on the left side over here, okay? This is where the illumination maps that we've been focusing on. The FBI is over here on the right, okay? And the FBI you can see running in their own cloud instance as well as running in the FBI data center, okay? Now, what we're going to do here is we're going to go back and I want to show you each one of the use cases. Just a moment, please. 1 second. I can't find my mouse because this is what Zoom does sometimes. 1 second. 1 second. Okay, so use case 5 is the TSA pre application running in GovCloud, talking to the FBI GovCloud instance, okay? We're gonna show you that. Use case 6 is the on-prem instance, talking to the FBI on-prem instance. Use case 7 is the on-prem instance of TSA pre speaking to the cloud instance. And use case 7 was on-prem to cloud. Use case 8 is cloud to on-prem. So let's go ahead and go back to our demo system. So first, let's approach this. Let's go back to our illumination map, and let's quickly orient you to a couple things that we have here. What we did was we modeled the interagency traffic in this location. One of the cool things I love about our product is we can model remote locations in a couple different ways. We can model them by using those IP lists that I talked to, and I'll show you that in an upcoming demonstration. But we can also model them using what we call unmanaged workloads, which are workloads on a remote system that we don't have our agent on, but we're going to model them as part of our overall policy. So in this case, we're modeling the FBI fingerprint application in this interagency app bubble. Okay. Now, what you'll also notice that our TSA pre-application is speaking to it, right? So it is speaking to it right here. You can see there's traffic going to it, okay? But we need to basically be able to write policy that allows that, okay? Also, once again, this application runs across multiple different data centers, and there's our GovCloud instance of it. So what we're going to do is go back and start writing our policies for this. So let's go ahead and look at the rule sets for it. So I've actually created a rule set here called fingerprint app access, okay? So what I wrote was for the TSA pre-application in the production environment across all locations, because even though the TSA pre-application I showed you that it's running on-prem, and I showed you it's running in cloud, what we do for that is we're going to write a rule that's going to govern what it can speak to on the outbound side. In this case, what I did is, and we'll come back to this in a moment, but I want to sort of fill in how we did it. What we did is we created a fully qualified domain name of database.fingerprint.interagency.fbi.gov. That is what the actual instance needs to speak to in the FBI environment. Now that is what we're going to do with that is we're going to write an outbound rule that effectively governs what that user can speak to. So in this case, the processing tier of that TSA pre-application can speak outbound to that IP list on that 3306 port that I was speaking to. So what this is effectively doing is maybe the FBI is using a proxy to forward that traffic. but we're resolving to the certificate and trusting the PKI of the FBI, and then only allowing it to speak out on this one TCP port, okay? So what did we just do? We effectively, we basically govern, and we created a policy that governed that interagency traffic that I just spoke to, okay? So now, what we're going to do is go to another use case from ATARC, okay? I'm going to pause for a second and get a drink of water, but while I'm doing that, I once again want to see if there's any questions from anyone that's watching right now, or any questions that I can answer via chat. Happy to do that. So let me just pause and have a drink of water real quickly. All right, so here we go, moving on to our next demonstration. So as it turns out, FBI also needs to interface with the iPause app, okay? So for this, what we're gonna do is we're gonna say, excuse me, we're gonna write a policy that's gonna only allow that the FBI to access the iPause app. So in this case, what we're showing you here is that something in the FBI data center, and it could be coming in from the cloud, can speak to iPause prod, okay? So let's get into our demonstration one more time. So first thing we're gonna do is we're gonna find that iPause app, okay? Now, here it is sitting in this one data center, and you'll notice that it's sitting here right now, and I've actually, let me just point out one thing here. Once again, I created an IP list. So instead of a specific FQDN inbound, what we did in this case is we allowed the IP address range of the FBI, or a very specific set of IPs from the FBI, to be able to speak inbound. So here we go. I said 10.1.4.45, maybe that's a proxy on the DHS network, and 64.34.0.0/16 that can speak inbound. Going back to my map here, my illumination map, and let's switch over to the application owner view for the fun of it. Here's that exact same application from the application owner view. What we see is here is that IP list, and here's who is allowed to speak inbound, the civilian partners, and down here at the bottom, you can see the FBI is allowing to have access to that iPause application. Here is actually the rule set that actually allowed it to happen, okay? One moment, please. The rule set is right here. The database is, oops, what did I do wrong here? I got the wrong one. So actually, why don't I go ahead and add it in for the fun of it? So I'm going to write a policy that says an IP list, which is FBI, access to iPause is allowed to speak to the web tier on port 443, we'll say. All right, 1 second, I'm in typing problems. I'll say, 443 TCP, okay? With this policy that I'm gonna write now is gonna allow the FBI to access it. I'm sure there's another rule set, but I forgot where I put it. Now, here's a cool thing about Illumio. We also have very tight controls over who is allowed to do what. So one of the things I like about the product also is I can say who is allowed to actually provision policies. So I can say, for the iPause application in the production environment, I can say who can be a rule set provisioner, and I can make it a local user, or I could use a user group from Active Directory. I'm going to give myself that capability, even though I already had it. I'm just trying to show you the demo of this, okay? So when I'm actually going to go ahead and provision that policy that I just wrote. Here is the policy that I wrote. You can see in sort of GitHub format, we can see which rule got added to this, and I'm going to go ahead and provision it right now. So when I need to write a rule, so this is for FBI access. So you can sort of have traceability on what got sent and provisioned. And there we go, it's provisioned out. And if I go back and look at my application instance right there that I was looking at, oops, I'll do it from the application. Actually, let's go look at that web tier right now. If we look at it, we should see an inbound rule on it corresponding to that, to 443. Remember, this was the FBI CIDR blocks that we talked about. So dynamically, we were able to update and write a policy that restricted access to and from that iPause application for our partner, which in this case was the FBI, okay? Now, what I'd like to do now is go back and talk about some things that are a little bit more esoteric, okay? So I'm going to show you a few different things here. So one of the things I didn't get into earlier is that we actually have, I showed you how we're doing it on bare metal servers, VMs, but also how we can do containers. So in this, oops, I'm sorry. One second. Containers, okay? So in this case, this is an application. Each one of these little octagons here is a container running inside of GovCloud, I believe, in this instance. So, so this is an example where we have container-based policies, not just bare metal server VM policies. So also, another thing that you can see here is I'm going to bring up that TSA pre-application. And one of the things I want to show you about it is an integration that we have. So I'm going to go to that application owner view again, and this is where this application is not just sitting in one data center, it's sitting across multiple data centers, okay? So we've been looking at it from the application owner view, and we can, from this, we can see what's talking into this application, like this fingerprint application is talking into it, okay? We can see what it is speaking to outbound, but also one of the nice things that I love about it is I can also show you this application, not just from a traffic view, but also from a vulnerability view. Be it integrations that we have with Qualys, Rapid7, Nessus, we can import vulnerabilities and overlay it on top of these application dependency maps to do something that no one else does, which is what we call a vulnerability map. A vulnerability map basically gives you information. And what you're going to notice here is the colors of the workloads have changed. Before, it was, the workloads now, the color of the workload corresponds to the highest exposed vulnerability on those workloads. And then you'll notice a couple things on here. If I mouse over it, you'll see how many systems are exposed to it. That's what we call the exposure score. The highest exposed vulnerability is a 9.4, which is a pretty high CVSS. And then the vulnerability exposure score is basically a measurement, is a combination of how many things by policy are allowed to speak inbound to it, but also the highest exposed vulnerability. In this case, because we've so highly segmented it, customers use these vulnerability maps to provide compensating controls until they're actually able to patch those systems. Another thing that I'd like to talk about is when you're kicking off your zero trust journey, you don't have to begin by cranking down everything to the finest grain segmentation. In fact, one of the nice things that we have in our product is something we call enforcement boundaries. Enforcement boundaries effectively allow you to begin enforcing policy, and they look a lot like deny rules. But instead of the deny rules worrying about rule conflict, the policy compute engine, that brain that I spoke of, understands the intent of what you're trying to accomplish, and it will always put the allow rules in the right place so you don't have to worry about it. In this case, if you wanted to basically block WinRM because you're worried that, about ransomware breaking out, I wrote that policy right there. I'm going to show you how you write one of these boundary policies really quickly. So let's imagine that, you really don't want Telnet being used inside of your environment. I'm going to do that right here. And the policy I write is that block Telnet. And what I'm going to write is all my workloads cannot speak to one another on Telnet right here, okay? So I'm going to save that. And so I have not yet enforced that policy, but also what we're going to do when we do this is we're going to show you before you go and enforce that policy if there's any traffic in your environment that's ever used Telnet, okay? Why do you want to do that? The answer is, let's imagine you have a legacy application that uses it. You don't want to break that, but maybe you want to go have a discussion with the person that runs Telnet. So by doing this, without breaking any of your applications, I've effectively blocked Telnet in your environment, but everything else is in visibility mode. That's an example of an enforcement boundary. So as you're building up your zero trust, you can incrementally start port blocking, and then while you're building up your broader network segmentation and micro-segmentation policies. Here's another type of policy you can write. So I'm actually going to delete this because I think I was practicing this demo yesterday and I forgot to reset it, okay? I'm going to go ahead and provision these rules real quickly. And I'm going to write a rule that's going to block development and production, okay? And here, because I want to sort of do this for illustrative purposes. So I'm going to write a boundary that's going to say, I'm going to block dev and prod. And so what I'm going to say is that development cannot talk to production on any ports or protocols, okay? So why am I doing this? Well, it's really a best practice to be able to separate dev from prod, and we all do our best to do that. But frequently, there's some type of commingling. What we're effectively going to do is we're going to put a boundary between development and production such that anything new that has to go from dev to prod, you will have to write an explicit policy that allows it. So I'm going to go ahead and save that rule, okay? And when I save it, I can also get a report about what will be blocked when I go ahead and provision this policy. Now, here is the thing about it, right? So I may say, I'm going to go ahead and investigate these connections, right? So instead of having to wait a long time to figure it out, what I could do at this point is say, you know what? I see these connections. I'm going to go ahead and allow that. I'm going to go talk to the people that own these systems and make them justify them. So I've basically put a perimeter or a barrier between dev and prod, but I didn't have to break those applications. So I'm going to go ahead and allow those, okay? So I've effectively just now created a boundary between dev and prod. I've stopped Telnet, and now I can begin to crank down my zero trust segmentation policy as I want to, okay? Nothing I've done today is going to preclude me from being able to get to zero trust. Okay. So now let's go back to our demo systems and what ATARC asked us to do. There was a question about how we can begin to troubleshoot, how we can troubleshoot, sorry, I think I've skipped ahead too much, troubleshoot a remote user. So let's talk about what some of those tools that we have in the product are. So there's a number of capabilities that we have. There's even a tab called troubleshooting. I can basically say, hey, tell me if an individual workload or an IP address can speak to one specific IP address. So I'm going to say can 10.84.13.1 speak to the core app 2, for instance. On port 443 TCP. So you can start asking it questions about what people are able to do in their environment. Sorry, one second. I need to move. I need to move something out of the way so I can actually see the windows. Can it speak to port 443 TCP? and it's going to let me know if there's anything that allows it, okay? Likewise, if I go to any given workload, I can actually see what the individual rules are for those workloads. So I can see both the inbound rules and the outbound rules. So there's that core app one. I can see the rules on it, both inbound and outbound, okay? Likewise, I can see if there's any blocked traffic. So let's imagine that someone tried to speak into it and we didn't have a policy for it. You would see one of three pieces of feedback. If the workload was in visibility mode, as this one is you would see that the traffic is potentially blocked, excuse me, meaning that if we had been in full enforcement, this traffic would be blocked, but because the user is not yet ready to, we let you know it's potentially blocked. If the workload is fully enforced, then you would see it actually being blocked, and if it was allowed, it would be allowed, okay? So that's another example of how we are able to do troubleshooting for the users. The other capabilities that we have in this place is logging, okay? So we have an unbelievable amount of logging and events in here. So I can tell you, like, you know, what exactly has happened over any given period of time. So I'm going to say, you know, let's see, I'm just going to run an open query here and see what's happening. And we can see what's happened that was a warning. So like, you know, did the VEN get its policy successfully? So there's a variety of different logging capabilities in the system that would allow you to troubleshoot a remote user. Next thing is, I want to make sure I did connectivity check, I did rule search, I showed you the event logs, but also something I've not yet gotten to, which is a really powerful capability, is I can run a query and I can say, tell me what is spoken to my my application. Sorry, I'm going to say my application of the iPause, or I think it's iPause, right? Tell me what's spoken to my iPause application at any given time. I'm going to go run this query, and it's going to let me know what is spoken in. And I want to show you that we show the traffic in a variety of different ways. This is what we call the parallel coordinate map. Here's my iPause application. I can see which IPs have spoken into it, and if so, on what port. We can see it's spoken on port 80 and what was running behind that port. Here is another view of that application, what we call a tabular view, and it's going to let us know if the traffic was allowed or not allowed. Likewise, if it was blocked by policy, but because this is not yet in enforcement, we can see the traffic was potentially blocked, and this was before I actually provisioned the policy. So Explore is another capability that allows us to do troubleshooting of that remote user. There's two questions. Okay, I'm fine there. Okay, so finally, I'd like to see, I showed you policy checks. Okay, so moving on to my next one. So what happens if a user has a compromised credential? So the first thing I'd like to point out about that is that when a user has a compromised credential, we are not the IDP or the authenticator inside of the environment, okay? But what we can do is we can show you if something is behaving out of normal, okay? So what I'm going to do now is I'm going to go back to Explorer, and I'm going to clear my previous query, and I'm going to say on my reported view, I want to know what has been blocked, okay? I need to rerun my query here, just a second. So I'm asking in the last 24 hours if anything has been blocked by policy. And you can see here that, sorry, this was reported view, okay? And then there we go, and I want to only look for blocked traffic, and I'm going to rerun my query here. Sorry about that. So I can see what was not allowed, what was happening that shouldn't have been happening, okay? So now I see that there's this blocked traffic here. I want to see if everything that this IP address was speaking to and go rerun that query. Was this basically someone doing some type of a scan across the environment? I can use Explorer, enter any IP, I can enter any workload and see what it's spoken to and see whether that traffic was allowed or not allowed by policy. I did it based on the last 24 hours, but I can also do that for any time. So now we're going to look back beyond those 24 hours, and we can see that it's tried to access this fingerprint application, but it's not exactly going low and slow across the environment, okay? So this sort of lets us know if something was doing a sweep of what's actually happening, we would see some type of reconnaissance happening within the environment, okay? Likewise, one of the things that we would look for is, hey, tell me on port 22 TCP, because that's one of the ways that someone might, in 3389 TCP, because those are the management interfaces. One of the things I would want to do if I was a hacker is go out, if I had compromised credentials, look for anybody trying to access my workloads using those specific management ports. So I'm going to rerun my query, and the query I'm running is, tell me what's talking into my infrastructure on port 3389 in TCP that was blocked, because that's an indicator of a compromised credential. And now I can see this IP address of 10.1.0.59 seems to be doing a lot of things that maybe it shouldn't be doing. That's something you might want to investigate. So that would basically help you determine if a user had a compromised credential, because we're monitoring. What we've effectively done with our product is we've turned every workload into a point of visibility. We've turned every workload into an enforcement point, which I've shown you, but now every single workload is a sensor. If anything is spurious is happening within your environment, you're going to know about it. And you're going to know about it because all these alerts that I talked about are going up to Splunk, ArcSight, and QRadar. There's something that I forgot to show you earlier, and I'm a little bit embarrassed about it, is I showed you how we do the bare metal servers. I showed you containers, but I'd also like to point out that everything we did inside of our Azure environment was done agentlessly, okay? So I forgot to show you that. Sorry, there's lots of demos going on here today, but showed you bare metal servers, we showed you VMs, and we showed you agentless, okay? And then finally, the last thing that we were asked to show you today was how we can help you through a pen test and give you evidence that you have the proper controls in place. So the answer to that is we're going to demo, once again, Explorer, which shows you the allowed and potentially blocked traffic. So in a pen test situation, Explorer can become your very best friend. So I can basically say, show me all my blocked traffic within the environment any given time, and you can begin to see and hone in on what might be actually blocking traffic. If somebody was trying to do a pen test, you can sort of find it. You think about, Explorer is sort of like Siri or Alexa, where you can ask it natural language questions. Like, I'm going to ask it, tell me what's talking on 3306 TCP right now, and it's going to tell us what's talking on that MySQL port that might be blocked. I don't know what the answer is going to be here, but you can see we very quickly can help you determine in a pen test if somebody's moving laterally, whether that traffic was allowed or not allowed. One of the other things you need to be able to do is you need to be able to provide evidence that your systems are actually in control. So I can go down to any one of my workloads here and look at their rules that are on them, and I can show you what the rules are for any one of these systems, and I can export them. So I can show you, was there a control between IP address A and IP address B and get down to the host? But I also showed you how we can do a policy check that shows evidence. So when a pen test happens, what I've shown you today is how you can do a microsegmentation down to the individual workloads, but also how we provide evidence that there's a control in place, and also that there's detection when the pen test is happening, that we can detect if something is happening. In fact, we recently did one for the U.S. Air Force, which appeared in their magazine, where they did an offense-defense, where Illumio was used to defend a set of applications from a set of offenders, and you can read about that. All right, and then finally, one last note. You can also see, like, one of the questions that people always ask is, hey, what if somebody's messing around with my agent? Here's an example. When somebody tries to touch the agent, we generate events, okay? And in fact, and I showed you earlier how every workload is in an outbound and inbound rule set. What that means is, if someone tampers with an agent, the first thing we do is we overwrite the rules on top of that host. And we send an agent tampering alert like the one that you see here, okay? The next thing that we will do is, if someone disables the agent, what we will do is it will pull it out of policy, and now things that were previously allowed to take connections from it will no longer take connections from it. So the policy compute engine is dynamically updating all the rules on all those systems to ensure that even if something goes wrong, you're retaining your zero trust posture. All right. So there's other evidence that we have. So there's a zero trust POC report for the U.S. Air Force. Excuse me. In the chat window, there's actually a link to the article that was published, and there's a Bishop Fox report that was basically a third party testing the efficacy of microsegmentation using Illumio. If you want to take the car for a drive and POC the product, just send an email to federal@illumio.com. So if you want to take the car for a drive, we have a variety of capabilities of doing it. You can try it with something we call the Illumio experience, which is a guided tour. There's zero trust architecture strategy workshops on demand. You have questions, there you go. And here's a link to our federal solutions page. And if you have any more questions, please contact Loy Awais on, here's his email address and here's his phone number. That is it for me. And I want to thank the ATARC team for allowing us to take part in this. And I'm happy to answer questions from the crowd. And if there aren't any, that's okay too.